Today we're going to look at a new topic, which is radioactivity. Now we understand that not all atoms are stable. Some atoms are unstable. So in this topic, we are going to be talking about the decayment of atoms. Why do atoms decay? And what causes that decayment of atoms? So for short, or to put it in simpler words, we know that stable atoms, they do not need to decay in order for them to be stable. They are already stable. Now when it comes to unstable atoms, they are supposed to decay so that they can attain stability. So we can simply define radioactivity as, so we'll simply say radioactivity is the spontaneous disintegration of the unstable nucleus. So I'm simply saying this is just the spontaneous disintegration of unstable nucleus. So that's the way we can define radioactivity. So it means you're talking about atoms being unstable. That's when they can decay. The reason why they are decaying so that they can attain stability. Now, if you look at the definition there, I've put up this word, which is spontaneous. Obviously, you understand that to disintegrate is to break into smaller particles. Now, spontaneous, you are supposed to know the meaning of spontaneous there. So you can simply say spontaneous. So it means that when these atoms, they are decaying, they are never affected by external factors such as human beings, temperature, pressure, time. It does not affect the disintegration of atoms. So I can simply say as spontaneous. This means without external influence. So it just means without external influence by such as pressure, temperature. You can also say time. Let's say etc. So we have a lot of external factors that can affect a lot of reactions, but in this disintegration of atoms, when it comes to radioactivity, it is never affected by these external factors that I've mentioned: pressure, temperature, and time. Now, it is also very important for you to understand that when atoms are decaying, they do not occur at the same rate. They occur at different intervals. So radioactivity is a random process. It does not occur at a specified time. That's why we call it a random process. It does not occur at the same rate. So we'll simply say radioactivity is a random process. So what does it mean to be random? It meaning it does not occur at the same rate. It does not occur at the same rate. So that's what it means there. So you need to pay particular attention to this word there. I've also specified spontaneous and random. So make sure you understand the meaning, because you might be asked to state what it means when you say that a radioactive substance is random or it is spontaneous. So you make sure that you understand those two terms there. Now, want to change is the format. From one element it goes to another element. So we know that when an atom, or let me say, the decaying nucleus is called the parent. Is called the parent nuclide. So the decaying nucleus is called the parent nuclide, or it can also be referred to as a parent radioisotope. So the element that is decaying is the one referred to as the parent nuclide, or the parent radioisotope. So you need to understand these two terms which are incorporated there. Then we know that if this process is taking place, it is going to produce another element which is going to be different from the original element. The one that is produced is the one that we call the daughter nuclide, since the parent is the one that is decaying. Then the one that is going to be formed is going to be called the daughter nuclide. So it's very much important you understand those okay, so it's very much important that you also understand the terms that are going to be using in this topic. So when it comes to when an element is decaying, it's either it's going to produce a type of radiation by emitting an alpha particle, a beta particle, or a gamma. So what is an alpha, what is a beta particle, what is a gamma particle? So it's much important that you understand those two, the three particles. So the first one, we say alpha particle. So the alpha particle. We can define an alpha particle as, so we'll say this is a radioactive, it's a radioactive substance that has two protons and two neutrons. Then we'll say it up, and let me say, and exists as helium nucleus. So that's called the two down there. So that's the way you can define an alpha particle. So that's the first one. So the second one is called the beta particle. So we simply say this is a radioactive substance that exists as a fast moving neutron. So that's the way we can define an alpha and a beta particle. So it's very much important to understand those terms there. Then the last one that we look at is gamma ray. So we can simply say this is a radioactive substance that is electromagnetic in nature. So that's electromagnetic in nature. So those are the three particles that we can look at. Okay, so those are the three particles that are going to be involved in radioactivity, and these are the ones that we are going to be talking about through this entire topic. So we've said that when an element is decaying, it can be referred to as a radioactive element, since it's decaying. Then the process is a random process, which is also spontaneous. No external factors affects the process of radioactivity. So you need to differentiate when we say spontaneous and also random. Random, it means that it cannot occur at the same rate. Then spontaneous without any influence from the external factors. So for today, this is where we end. Then in the next video, that's when we're going to talk about background radiation and going further. Thank you.